Yep. Hey everyone, thanks for dropping in. So we're gonna wait for a couple of minutes for other folks to join in as well, and then we can quickly get started with the workshop. Hey Anish, hey Mirinbhai.
Oh, there's already a bunch of people in here, which is nice.
Yeah, people are super excited to learn more about Gelato and are looking to use them in their projects at Eternals. Yep. Yeah, so I think we can just wait for another minute in case if there are more people joining in. Meanwhile, I'll give a quick introduction. So with us, we have Hilmar today, who's the founder at Gelato. And we'll be covering about the basics of how to leverage Gelato to automate your smart contracts in your dApps. And there are also some exciting prizes up for grabs, worth $5,000. And Hilmar will be covering everything about the bounties and also the platform itself. So I think we can start. All good?
Mm-hmm.
All right, handing over the stage to you.
Sure. Hi, everyone. Welcome to today's session about Gelato and how you can automate your smart contracts using our decentralized network of bots that is available on most EVM-based compatible blockchains. And yeah, so I will be diving into why Gelato, why you need it, with a very brief slide deck. And then, but before that, I will probably talk about the bounties. A lot of people are here probably to hear about that. And yeah, then we actually go into the code and we will write a couple of examples ourselves, and we will try out how you can actually use Gelato in different sort of ways. Some are easier, some are a bit more advanced, and you can kind of like pick and choose what you want to kind of like include in your hack. But yeah, maybe to just get started, let me just quickly share my screen here. Share. Cool. I think you should be seeing this right now.
Yep, we can see your screen.
Cool. Awesome. And yeah, so maybe let's start with the bounties, guys. I know you guys are excited about the bounties. We have $5,000 up for grabs for this hackathon. And actually, we have a total of 10 sort of like grants or 10 bounties you can win, $500 each. And it's actually pretty straightforward how you can earn these $500. Yeah, so the only thing you have to do is you have to use Gelato, and I will go into how you can do that later in this talk. You have to use Gelato to basically automate certain aspects of your decentralized application or your smart contracts that you're building, right? And actually, if you go to app.gelato.network, this is kind of like our web app. And what you can see here is actually there's like a leaderboard, and this leaderboard is like a live leaderboard of all the different projects that are using Gelato for all sorts of different use cases, from automatically padding Aavegotchi NFTs on Polygon to updating time-weighted average prices to harvesting yield farming vaults, right? So there are like a lot of these different tasks, and people have created them, and they are just automating certain aspects of the applications using Gelato. And you can click on them, you can check out the contract that they deployed, the function that they are automating, and then like how often, for example, they want to execute this function, this particular instance, every 6 minutes, right? And then when was the last time something got executed, and so on. So basically, the only thing you have to do is you build an application. I don't know, let's say you build an NFT, right? And this NFT has a particular function that can be called. And when this function is called, something happens when the NFT, I don't know, it changes, right? So, and you want to call this every, I don't know, 10 minutes, or every time the price on Uniswap changes to a certain rate, then you can just create a task on Gelato and automate that. And if you do that, and it kind of like works, and you have some transactions that got successfully executed here, then you are eligible to win one of the bounties, and basically the 10 dopest tasks and the most creative tasks sort of have the chance to win one of the prizes, right? So, and for example, this task here already got executed 20,000 times, for example, right? Which is crazy. But yeah, before we start how to kind of like do it, let me just give you a quick walk down of what Gelato is and why it's needed and all the boring stuff associated with it. No, it will be fun. You will learn a lot. And yeah, I think afterwards you will have a much deeper understanding of like the EVM and why you need something like Gelato, right? So let's, as an example, right? We have this contract here, and you can think of this contract as kind of like your lunch money contract for your children. Maybe you're probably a bit younger, some of you might be older, but let's say you have children, right? And let's say you have 3 children, and every day at lunchtime, you want to send them their lunch money. Let's say it's like $5, right? And in order, and rather than kind of like sending them like $500 up front for 100 days, you want to send them like $5 each day, because, right, otherwise they would just go out and they buy a bunch of ETH, and then ETH crashes, and then they have no money to buy their lunch in school again, right? So this is not really optimal. They don't make wise investment decisions as children. So you want to send it to them on a daily basis every 5 minutes, right? And let's say you have this payout token function right here, and this function just automates the payment. This function just pays out for all your children a certain amount of ETH, for example, right? But obviously you don't want to go there, and you don't want to log into MetaMask every day at lunchtime and execute that function, right? You want that function to just be automatically executed every day at 12 p.m., right? How do you do that? We will go into that today. This is a very simple example, but this function can be automated using Gelato. But yeah, so before we start with that, why do you need that, right? And the first realization, maybe if you're just getting started, is that you have to understand that smart contracts, they are not smart. They are quite dumb, they are quite lazy, and they actually, the only thing they do is they define certain rules and certain logic. And this logic kind of like determines how state in the EVM can be altered or can be changed, right? You have these functions and you define, hey, I want to change this state in the EVM and I want to update this balance from 10 to 12, for example. But this logic is not just triggered automatically. It will only be executed, and the state changes you want to do will only get triggered if you actually, or someone, sends a transaction to that particular smart contract and executes the logic. If no one sends a transaction, nothing gets executed, right? So important to understand, smart contracts, they don't self-execute conditionally or recurringly. You have to do it, or someone has to do it. Well, why is that, right? Why wasn't it baked into the system, right? So you have to kind of like differentiate between 2 sorts of kind of like automation, which is endogenous, so internally into the EVM, and then exogenous, like externally. So why isn't that? Why can't you just say to the EVM, hey, please execute it every so often, right? Because like the EVM is just run on all these clients all over the world, and let's say if you would kind of like encode an infinite loop into one of these functions, it would just run forever, right? And then because transactions get mined sequentially on Ethereum, you would just have one transaction that just like takes forever, and no other transaction will get in anymore. And yeah, the whole kind of like network will clock and will go down, and yeah, this won't work, right? So you can't have these infinite loops run inside the EVM, right? So what you have to do is you have to kind of like run them outside the EVM, but this is actually super expensive. Let's say you have like 10,000 tasks that you have to constantly check. Like having this be done in the clients of Ethereum, in the Geth clients, for example, themselves would mean they have a huge computational overhead associated with actually automating these transactions. And because the whole point of Ethereum is to make it so that everyone can run the nodes, having higher computational requirements leads to higher centralization, and this kind of like defeats the whole purpose of Ethereum, right? So basically what that means is automated transactions on Ethereum or on all other EVM-based compatible blockchains has to be done by an external network outside the EVM, right? And this is exactly what Gelato is basically. And so automation, how does it look like in Web 2? you have like cron jobs, you have cloud-based job schedulers like AWS CloudWatch. And yeah, maybe we could just have a quick look if you can actually use these services to automate your smart contract as well. And it turns out that you could kind of like hack together a nice POC that kind of like does that, but there are a lot of small details here you have to consider when actually trying to build something reliable, scalable, and well-functioning for automating your smart contracts, right? And these are just like a bunch of stuff you would have to do. You have to listen to events. You have to check like the state and events every single block on Ethereum. And if you actually want to do this on Polygon, you have to check like every 1 or 2 seconds when a new block hits, whether something gets executable. Then you have to have on your externally owned account that sends the transactions to automate certain functions. You always have to have an ETH balance or a Matic balance. And if you don't have that, right, you won't send the transaction. You need to get alerted when your balance is low so you can top it up. And then there are like a lot of edge cases, like you need to handle reorgs, you need to simulate transactions, whether they're not revert, you have to handle the RPC unresponsiveness, because I would assume you won't run your own full nodes, right? So you use something like Alchemy or Infura, but sometimes they're unreliable and then your whole thing crashes. And yeah, there are a bunch of stuff. Resubmitting transactions if they're stuck is really important. Let's say you have 100 transactions that need to be executed right now, and one of them is stuck with the lowest mons, then no other transaction will get mined until this transaction, the first one you sent, gets mined, right? And this could have your whole application go down. So yeah, it is quite the overhead, as you can imagine, right? So enter Gelato. What is Gelato? Gelato is basically Web3's automation protocol. It's a one-stop shop for you to automate arbitrary functions on your smart contracts, be it, hey, send the lunch money to my children every day at 12 p.m. or, hey, I have this yield farming protocol that I built. Please always recompound the interest earned when it's worth it, given the current transaction fees. Or I've got this Oracle that I need to update every 5 hours. Hey, Gelato, can you please do that, right? And the architecture, how it looks like, is that we have, this is kind of like on-chain. These are the smart contracts on the top, and on the bottom, you have like the client side, what is in the Gelato clients that comprise the Gelato network. And at the top, you have, first of all, a job scheduler smart contract. This is the contract where you go and you can like define, hey, I want to call this function and I want to call this function if this condition is true. Then the resolver is kind of like the condition. So when do I want to execute it? And the target is which contract and which function do I want to execute? And you basically take the resolver, you take the target, you encode the data, you give it to the job scheduler, and this job scheduler emits an event, which is then queried and fetched by the Gelato operators called the executors. They then now know that, okay, I need to automate the function of this particular smart contract for this particular person. And then they constantly check whether this can be executed. If it can be executed, it will relay the transaction to the specified network, and you can specify any EVM-based compatible network, and then they will execute the transaction on your behalf reliably and scalable, right? And the benefits are quite clear. You don't need to self-host anything. You don't need to run servers, nor on the cloud, nor locally. So it's completely serverless. You can just deploy smart contract to Ethereum. You can deploy your UI on IPFS. You can automate the transaction with Gelato, and then you're not running anything, right? That's dope. Then you don't have to worry about RPCs, basically having to deal with failures and being always connected to the networks. Gelato kind of like handles that all for you. You don't have to worry about stuck transactions. Gelato always makes sure they get mined and resubmits the transactions with higher gas prices if needed. Like edge cases like reorgs and everything are catched by Gelato. You have native multi-chain support. This is really an important one here. Like if you, let's say you spin up your own AWS instance to like automate some transactions, then like if that instance goes down or this particular server goes down or you forgot to pay your bills, your application that relies on this function being automated every so often will go down, and it's not a decentralized application anymore. It's very, very centralized, and that's why Gelato is cool, because Gelato is a ready-made decentralized network. And if one bot goes down, then we have like 10 others that can execute a transaction, right? Also, an important feature is that you actually don't have to manage any private keys in the cloud. This is always like an important topic, right? If you have a bunch of ETH in there, you don't want to lose it all. And yeah, so Gelato actually has a built-in consensus mechanism in place so that it coordinates different bots, different executors that want to execute transactions, and then like at certain times this executor can execute, and at other times this can execute, right? So they don't kind of like race each other, and one gets in and the other one doesn't. Yeah, so without further ado, I will actually want to just jump into the code and show you guys how to do it. And this is kind of like a teaser. You can just paste in a contract address, and then you can define when you want to execute it. And then once you define it, you can create a task, and bam, you're actually done. This is the cool thing of how transactions can be automated using Gelato. So first use case we will dive in is we want to create a very, very simple task that just on like a time interval executes a certain transaction on Ethereum, or in our case, we will actually use Polygon because it's just cheaper or just easier to show right now. And for this particular use case, we have an ice cream NFT. It looks like this. And this is actually like a dynamically changing NFT. So there's this function on there called lick. And if you lick it, in the NFT, there's an SVG stored, and one ice cream scoop disappears after another, and you end up with like none, basically, after some time. So, by the way, are there any questions thus far? If yes, feel free to just jump in and ask. Otherwise, I will continue.
I can see some open questions in the Q&A box. All right. I think some of them we can take it towards the end.
Yeah.
Yeah, I can see one question. Can we use Gelato on other L1 chains and on Polygon?
Yes, sir. So here are the current supported ones. You have Ethereum, Polygon, Phantom, Arbitrum, Avalanche, BSC. I think Optimism is kind of like missing here. And yeah, we are supporting more and more as time goes by, but these are the ones you can use right now.
That's good. We have another question. Does Gelato take extra gas fees than the normal transaction?
There is, so first of all, at the moment, there's 0 fees associated with that. So you basically, if you would execute a transaction, you would pay exactly the same amount with Gelato. Though like with Gelato, there is a very small gas overhead for each transactions, because we basically have some security checks in a smart contract before your transaction gets executed, but these are especially on like non-Ethereum chains, like negligible, so you shouldn't worry about them too much. Cool.
Yeah, I think we can take the
we can continue, right?
Too. Yep.
Cool, awesome, right? So here's our smart contract. It's on Polygon, and this is the kind of like ice cream NFT. And the ice cream NFT has this function. It's called lick. You can pass in a token ID of the token you have. And as you can see, there's like a require here, which says, hey, you can only lick it every time this threshold has passed since the last lick. And this threshold is like 5 minutes. And because if you lick your ice cream more than 5 minutes, you get brain freeze and it hurts, right? So you shouldn't lick your ice cream too often, right? So this function, of course, we don't want to lick it manually every 5 minutes and click, lick. We want to automate this. So let's try to do it. Only thing we have to do is we kind of like copy that address. We go to Gelato. We click on create task. And what we do is we just paste it in. If you verified your smart contract that needs to be automated, it will fetch all of the functions automatically from Polyscan, Etherscan, or whatnot. And you can just like select them from a dropdown. If not, then you can actually just input a custom ABI. After you compiled your smart contracts, you just dump in the ABI here, and then you can select the functions from there. In this case, we want to make it very easy. We just have a token ID. The token ID of my NFT is 1 because I was the first one who minted it. Yay. And now what I can do is I can just say, hey, I want to execute this function every 5 minutes, right? And then like in 5 minutes, it will execute it. Then after 5 minutes, it will execute again, and so on, right? So now it's the question, okay, who pays for these transactions, right? And obviously I need to pay for the transactions. And so what I can do is I can just go here and I can deposit 5 Matic in here. And then this will be topping up my Gelato balance. You can think about it as sort of like a prepaid SIM card that you have where you top up $20 and then you can use that $20 to execute transactions, right? So we deposit in $5 here. I won't go do this right now, but you can, and then you can just say ETH India, take my ice cream. Right, this is kind of like the task, and then you can hit the create task button, and then it will create the task on your behalf. And I already kind of like done that at the beginning, and this is kind of like how it looks like. You will then get this sort of task page where you have the contract you want to automate, the lick function, did you want to do it every 5 minutes, and then all the transactions that kind of like occur of the licking every couple of minutes, right? So this is kind of like the easiest way to get started. If you just have one function, you can predefine the inputs to that function, and you just want it to be automated with kind of like a time interval, right? But there's more, and there's more complex things, and we can go into them right now. And this is kind of like what we call creating a resolver-based task. And what a resolver is basically just a smart contract that defines when transactions should be executed, right? At the previous example, we just had, hey, please execute my transaction every 5 minutes. But now we want to have a more kind of like custom condition. We want to say, for example, hey, please execute my transaction when the fees that are accrued in this particular contract that I have exceed a certain amount of money, right? And as an example, we will use the example of a yield aggregator. And in case you don't know what it is, it's like yield farms or yield aggregators. What they do is basically they deploy so-called vault smart contracts. In this vault smart contracts, they have they pool funds from users, and then they kind of like farm basically the farm rewards on particular tokens. You can, for example, deposit your USDC in there, and then they go out to Aave and they farm Aave rewards, and then every time Aave rewards get accumulated to a certain extent, they take these Aave rewards, they sell them back to USDC, they put the USDC back into the pool, and then you have kind of like this compounding effect on the Aave rewards that you earn, and it always gets compounded back into your DAI vault. And basically they have this function which is called harvest vault, and you can pass a vault to that. And basically what it does, it will basically do the recompounding by kind of like getting the fees, getting their earned tokens, swapping it on Uniswap, and then depositing it back into the vault, right? And basically what we want to do is we want to automate calling this particular harvest vault function every time the fees that were accrued are so big that the transaction fee that is necessary to execute that function is less than 5% of the fees that have been accrued, right? It sounds a bit complex, but bear with me, we'll figure it out. So this is kind of like, and in order to do that, we have to write a resolver smart contract and deploy this, okay? And the resolver smart contract, like the basic thing basically looks like this. So you need to have a smart contract here and Solidity, and then there has to be a so-called checker function. And the only important thing, maybe let me just increase that here, just in case you can't see that. There is, the only thing you need in this resolver function is a checker function. And the most important thing is a view function. And it actually doesn't have to be a view function. It can also be a non-view function. But what's important here is that it returns two values, and these are a Boolean and a bytes payload. And the Boolean is telling Gelato, hey, is this transaction ready to be executed? And the payload tells Gelato what function to execute and with what data, okay? So we have this, let me just delete this one. We have this harvest vault function, and this we want to automate, right? But the question is, okay, what vault should be passed to this function in the first place, right? Let's imagine we have 100 vaults, and we need to check all of these vaults if they can be recompounded, if it's worth recompounding them, right? So how do we do this, right? So first of all, I would say, okay, we need to kind of like loop through all these vaults, and we need to find out whether each one of them can be harvested or can be recompounded or not, right? And for that, we have this get vault length function here, which enables us, which gives us basically the number of vaults. And we have this get vault function. There's an index, and we can basically check at each index what sort of vault there is, and we can just check each vault with that, right? So what we do is we will just start out here with like a simple for loop right here, right? And then we say, okay, we need to have this vault manager that I defined, the vault manager I defined earlier here in the constructor, right? It's the other smart contract that we have. And there was this get vault length function on there that we want to call. And yeah, we just want to kind of like iterate through that. And this kind of like will enable us to iterate through all the vaults that the vault manager has stored. And then what we want to do is we want to define a vault. This is the interface of the vault, right? So let's just define this interface. Let's call it vault, and it's equal to iVault vault manager. Vault manager, can I spell manager? I think so. And then get vault, and then we have to pass I as the index to this vault, right? So this would kind of like give us the vault. And now we have the vault in here, and now we want to check, okay, should we actually harvest this vault and recompound the fees or not? And for that, I think we can just like write a small helper function right here, which is say function should execute harvest, right? And what we pass here is the vault called vault. And what we do is we view function and we return a Boolean whether this vault should be actually harvested or not, which is pretty simple, returns not return. And basically what we can just do is we can say, okay, the vault that we have passed has a function is called accrued fees, right? If you go here, accrued fees, should be here at least. Yeah, so this is the vault manager contract, but the vault contract has a function called accrued fees, and what it does basically returns to you how much fees have been accrued in this particular vault, right? And then what we can do is we can say, okay, we want to multiply this by 100, okay, and then we want to divide this by 5, and it's kind of like, hey, 5% of the fees accrued in this particular vault must be greater than and this is actually value that I have defined previously. So like what this says is basically, hey, this like calling the harvest function on a particular vault will consume roughly 300 K in gas, right? So this is kind of like the approximate gas overhead on Polygon or Ethereum to actually call this function. And what you can do is if you want to get an estimate of the transaction fees that you will have to pay for Gelato, you can say, okay, we want to multiply the gas per harvest times actually the TX gas price that Gelato is using. And this gives you, okay, the approximate transaction overhead. And what this gives you is kind of like, okay, this is the number of fees that have been accrued, let's say 100. And now I want to see if 5% of the accrued fees is greater than what I would pay to harvest this function. And if this is greater, then, okay, return true and actually tell Gelato that it should harvest this particular vault, right? So what we can do is we can just take this function. We can put that here and we can pass the vault to it. And what we want to do is we want to actually store that in the canexec Boolean that we already defined right here, right? And this Boolean tells Gelato when to execute, right? And if this returns true, then Gelato knows, okay, please execute, right? So this is, let's say it returns true, right? For this particular vault, right? Then we still need to tell Gelato, okay, what function it should now execute, given that it knows it should execute, and with what data it should execute it, right? So what we want to do is we want to have like, hey, if canexec, which means, hey, if we should execute, right? So given that can execute is true, the exact payload that we define right here, right, has to be equal to ABI, and now we need to ABI encode the selector. Basically, you need to encode the data for Gelato. Selector. And then what we want to do is we first want to get the function selector of the particular function that we want to execute, which in this case is the harvest volt function, right? So this is how you can like get selectors in Solidity. And then what you do is you pass an address, which is the address of this volt, to the particular function, right? And then since this is kind of like in this case, you would be you would be happy with like, hey, please Gelato, I found the volt that should be harvested. Please take this, please call the harvest volt function, this one, and pass the volt that should be harvested, right? And then we want to, of course, break out of this for loop because we don't want to override it, so we just do like a break here, and it will break out. And then what you can do is, let's say, there were no volts that can be harvested at that given moment in time, right? What you can do is just for debugging purposes, what I would always suggest you to do is you can just say, hey, the exact payload should be bytes, and then you can kind of like have like a string here that tells Gelato, and you can actually then display this on the UI. No volts are currently harvestable, right? So you can just display that. And then on the UI, you just see, hey, volts, no volts are currently harvestable. But if it's harvestable, Gelato knows what payload to use, right? And so basically, you can just write that. And then what you do is you would use hardhat deploy to deploy this thing. I won't go into that. You should check out the hardhat deploy docs if you want to do this. But luckily, what I did is I already deployed it some time ago. So this is the volt resolver. And do we have this here? This is the volt manager. This is the one we want to execute, right? And this is the volt resolver right here. This is what we define. So what we want to do is we go to, this is the old one. We go to Gelato again, right? We click on create task. We take the volt manager. This is the smart contract we want to execute. We put it in here. And it fetches the ABI right away. And there's like these functions that are on there. And for us, the relevant one is the harvest volt function. Now, we could create 100 tasks and pass in the different volts manually here. But as I said, it's much easier to just have this be dynamically checked by a resolver contract. So what we choose is we choose dynamic inputs via resolver. And now what it will ask us, hey, can you please give me the address of the resolver that you deployed, which I can gladly do. Pause it in, and then again, it will ask you to select a particular function. You can use this checker function, for example, and then you can click, you can deposit some funds again, and you say, harvesting my volts, so to say. And if this all looks good, you can hit create task, and then it will ask you to execute this particular smart contract function, and then you click confirm. And now we basically created the task. Once this is mined, we will be redirected to the task page. And then on the task page, we basically see all of the information that is necessary. And yeah, because I already created the task, there was a bug now. We should catch that, of course, beforehand, but basically I already created the task. So that's why it doesn't work. But yeah, so this is basically how you can create a resolver-based task. And actually, this was a real-life task. If you go to, are they on? I think they're on Polygon. Yeah, this is actually kind of like the function that I used is kind of like stolen by ETH-A-Land. They are like a yield harvesting protocol. They use Gelato, as you can see right here. And yeah, so shout out to ETH-A-Land for stealing your code. And they basically already did that. So I basically showed you like a real life use case of a particular customer that already uses Gelato. Cool. Then finally, before boring you to death, I will show you how you can actually use Gelato without having to deposit money in it to pay for transactions, right? And for that particular use case, let's switch to Ethereum. We're doing some mainnet shit now. And there's this task right here. And kind of like you can see, it kind of like executes every so often. And what it does is it looks like this. I probably you heard of convex. Maybe you heard of convex or maybe not. But basically, without going into details here, the convex smart contract, the convex staking smart contract is a publicly callable smart contract function, so everyone can call it, right? And this particular function, smart contract, has a function called distribute. And what this does, I don't know, it distributes rewards or whatever. I actually don't know what it does, but it does something, right? So what someone did here is actually they deployed the smart contract which wraps this distribute function in another function. And actually, when you call this distribute function, what you receive is convex tokens. And you receive these convex tokens because you obviously call this function. This function has to be called every day or something. And you have to pay transaction fees on Ethereum mainnet, of course, right? They could be like $100. So you need to get compensated for calling this function. So what they do is when you call it, they send you convex tokens, which is great. But you, of course, if you want to automate this with Gelato, like Gelato doesn't accept convex tokens yet as payments, right? So you need to convert these convex tokens to ETH and then pay Gelato with ETH, right? Because you don't, let's remember, you don't have a balance here. You have actually, you can define that you want to execute this function by having the transaction pay Gelato directly rather than you having to have a pre-deposit balance on there, right? So what you can do is you can basically call this function. Now, after this function is called, this particular smart contract here, the CVX distributor, will receive CVX tokens. And what you can then do is you can basically take the CVX tokens and you can swap them on Uniswap for ETH. Okay, and the ETH is kind of like defined here that you want to swap to ETH. And then what you just do is you can call Gelato and you can call the function get feed details. This will basically tell you on chain how much you need to send to Gelato in order to pay for the transaction, in order for the transaction to go through. And so you take the fee, you say ETH, and you transfer that to Gelato. And then there's kind of like maybe there is something left over here, right? So maybe there's some leftovers here. And what you can do is you can actually take that leftover and you can just send it to, I don't know, your own address, for example. And this is how we can actually make money by just calling certain functions on Ethereum and having it execute by Gelato. And what you just have to do is you have to deploy this. And this is kind of like the address of the deployed instance of this particular contract and how you would actually create the task and do it. You would go to create task, you would input it, you will select the distribute function. And now the distribute function, basically, it will revert every time this payment to Gelato will not go through, right? So it will only actually not revert when the payment goes through, and we will actually finish this function without reverting, right? Which means we actually don't need to define any condition here. We can just say, hey, Gelato, whenever this function, the distribute function, whenever it doesn't revert, please execute. And super simple, just select whenever possible. And now Gelato will just check whether this can be executed. And if it can be executed, then it will just go and execute it. Now, you don't need to define any balance here. You can actually just say, hey, the transaction will pay for itself. I don't need to pre-deposit anything. And what I will do is I will select ETH as a token and then automate convex distribute. Right? And this is basically all you have to do. You can click create task, but I don't want to do it because I'm a mainnet here. And this is then how it looks like. This is basically the same task. And here you can see how often it executes. And then you can see all the details around, right? So this is also possible. You don't need to pre-deposit anything and you can literally automate anything on Ethereum. Yeah, so, right. I think we are kind of coming to an end here. Guys, make sure to check out this this UI that we built, app.gelato.network. You know now how you can like schedule automations, time-based or arbitrary condition-based. Check out the leaderboard to get kind of like inspired what other people have built. They automate strategies, they automate harvesting, they automate rebasing of algorithmic stable coins, they automate any cool stuff that you can do on these blockchains, right? So what you have to do is set up a task, have a function that you want to automate this function. Think about, okay, what cool things can I automate in DeFi, in NFTs, in gaming, right? Build it, automate it, have certain transactions be executed, send us this task, basically take this link, send it to us, and then we can check it out. If you want to join us in some socials, we have Twitter, but the best way to communicate to us is kind of like on our Discord right here. Go to the Gelato Discord. The links should be on our website and stuff. And from then onwards, I think you will be good to get in contact with us. And yeah, looking forward to seeing your tasks. And the coolest one will win $500 each. So make sure to build something cool there. And yeah, if you have any questions, now is the time to reach out to us. Yeah, thanks.
Thanks a lot, Hilmar. So you can just go to the Q&A section. Can see a couple of questions. Where can we find the tutorials to automate the smart contracts?
Second. Where can we find the tutorials to automate smart contracts? I think June will probably post some links in the chat right now, but we have some YouTube tutorials. We have our docs, which I will just input here in the chat. So you should just be able to check out our docs, but also just Google on YouTube, type in Gelato network, automate smart contracts or something, and then you should be able to find some kind of like video tutorials.
We have another question by Sai Mendra. Is Gelato compatible with all versions of Solidity?
Yeah, it doesn't matter.
But as per definition of smart contract, it is self-executable. How does Gelato come into the picture?
Could you repeat that?
But as per the definition of smart contracts, it is self-executable. How come Gelato helps? How does it help basically automate smart contracts?
Yeah. If you would have listened at the beginnings of my talk, you would have known that smart contracts are actually not self-executable. They just define logic and state, and someone else externally has to actually execute them for them to execute the logic that you define within them. So smart contracts are not self-executable. Only if you add Gelato to the picture, they will become self-executable.
Does Gelato have plans to expand to other chains like Solana or EOS for cross-chain ETH event handling?
Yes, sir. We do have plans, and we will basically expand to all the networks that are available. And maybe it's just kind of like as a teaser to what we have planned in the future is we will actually soon enable developers to not only like automate, let's say, a particular function on Ethereum, but what you can soon do is you can say like, hey, if the interest rates of DAI in Aave are higher on Polygon than they are on Ethereum, please automatically move my funds from Ethereum over to Polygon and deposit them there. And then maybe in 2 months, when this changes again, deposit them back. So you can actually do cross-chain automation, which is kind of like the next big thing we're working on. And this will be pretty dope.
Sounds good. Basically, like people just want you to elaborate more on like the terms like RPC, ABI. Just a quick explanation so that
what is an RPC? Yeah, sure. RPC is basically the way how you communicate with the blockchain or with a particular network. Let's say you want to read data from Ethereum, or you want to write data by sending a transaction to Ethereum, right? You need to communicate with Ethereum somehow, right? How do you do that? Actually, you communicate with full nodes, right? So with people running the Ethereum client, and basically what these clients expose is a so-called RPC endpoint. And this RPC basically is kind of like an API. And this API enables you to basically ask this node, hey, what is the current state of my balance of USDC and you read it, or you can actually say, hey, Node, can you please take my transaction that wants to transfer some money to a friend? And can you please make sure it gets relayed to the network and at some point picked up by a miner who then includes it into a block. So it's kind of like the communication gateway of how you as a person or anyone can communicate with the blockchain.
Sounds good. Can we automate for free on Gelato for testing?
Sorry?
Can we automate for free on Gelato for testing?
Yeah, so we support Gurley, we support Robston, I think we support Ringby. So there are like a bunch of test nets where it literally costs $0 to test stuff. But I don't know, if you, for example, use Polygon, then you can test stuff like for like 50 cents or $1, right? So if you need that, like let me know, I will send you a Matic or so, and you can also test it on there. But like Gurley, for example, as a testnet works fine, and just use that. And it's completely for free, but you need like testnet tokens, but they are like facets where you can get them.
We have another question. That was a great demonstration. Thanks. My question is regarding whether Gelato can automate more complex tasks, such as if one function transfers some ERC20 token to say 100 addresses in one function call, or will that be very expensive?
Yeah, it works. This function will of course consume quite a lot of gas, right? But it doesn't matter. Like Gelato can execute transactions that consume 40,000 gas units or 4 million gas units. Gelato doesn't really care about it. Yeah, like transactions that consume 5 million gas are being automated by Gelato right now. But it should be less than the block gas limit, because if it's higher, then yeah, it won't work.
Let's take one last question, and then we have the Gelato team also on our Discord. So feel free to drop your queries on the channel itself, and we can take it async. Just one question: who pays for the gas fees for a contract run every hour? Can you run a contract at a future specific date?
So who pays for it? Well, the person who wants to automate it pays for it. So if you want to automate it, let's say you have a project and this project relies on this function being automated, then usually you pay. Yeah, so and I showed you like the two ways of how you can pay for it. Either you pre-deposit it into your Gelato balance, some ETH, for example, or you encode the logic that pays Gelato into your smart contract right away. So these are like two ways of how you do it. And what was the second question again?
Just give me one sec. Second question is, can you run a contract at a future specific date?
Yeah, you can execute. If you mean, can you execute functions on a contract at a future specific date, then yes, you can just define it in the interface and say, hey, I want to execute it I want to execute it starting next week, Monday, and then every 5 hours or whatever interval you want to choose.
Sounds good. We can probably take up the rest of the questions on Discord itself. And thank you so much, Jun, for posting all the tutorials, Discord, every possible way to help out people who are interested on building on Gelato. So would like to thank Hilmar and June for joining us, helping our builders understand more about Gelato and how they can leverage it in their own dApps and get some chunk from the bounties being offered. So thank you very much.
Awesome, guys. Thanks a lot for having me. Let us know if you have questions, and of course, have fun building. It's all about kind of like enjoying yourself and learning, right? So yeah, catch you in the Discord.
Yeah. All right. Thanks, Elmar. So for the rest of the builders, we have like a quick quiz on Gelato. So we have Amazon vouchers up for grabs. So I'm just dropping the link in the chat here. You have 15 minutes to answer the quiz, and we'll be announcing the winners tomorrow. Thank you so much, Ilmar and Ju. So I've already dropped the link to the quiz in the chat. And you have 15 minutes to answer the questions. Hey, so yeah, the metaverse will be opening it tomorrow. Today we have some workshops lined up. We have our next workshop by Chainlink starting in a couple of minutes. So make sure you drop over there as well. And we have like another quiz waiting for you at the end of the Chainlink's workshop. All right, I hope everyone has gotten the link. Thanks everyone for joining in, especially on a holiday. And I hope you learned a lot about Gelato and will be using it in your dApps at Ethereum. See you folks. See you at the next one.